Hello students, in this video I am going to discuss the contents of the unit number 2 for the subject computer aided engineering. Title of the unit is meshing technique. This video will be particularly useful for you during the revision of this subject at the time of examination. So the content of the unit are discretization of a structure, 1D, 2D and 3D elements, meshing, then element selection criteria, refining mesh, effect of mesh density in critical region, use of symmetry, then element quality criteria. The different quality criteria are Jacobian, aspect ratio, warpage, minimum and maximum angles, average element size, minimum length, skewness, tetracollapse, okay, etc. Higher order element versus mesh refinement, geometry associate mesh, then next is mesh quality, bolted and welded joints representation, and the last topic is mesh independent test. So the probable questions which can be part of your end semester examinations are, we will go through these questions and I will try to explain you the answers of these questions in short in this video. So first is explain the mesh refinement in detail. So mesh refinement is basically increasing the density of the mesh. The density of the mesh you can increase by increasing the number of nodes or by increasing the number of elements. So when you increase the density of the mesh by increasing the number of nodes, it is called as P refinement, and when you increase the density by increasing the number of elements, it is called as H refinement. So you can explain these points with the help of suitable sketch for P refinement and H refinement. The second probable question that can be part of your examination is write short note on use of symmetry in analysis. So there are so many geometries are there which are symmetrical about one particular axis. So in that case, instead of going for the analysis of the entire geometry, you can consider the portion of the geometry which is symmetrical for the analysis. So it will reduce the time for carrying out the analysis, and also the mathematical calculations which are required to be carried out will be less, and the results of this the result of the analysis you can apply over the entire geometry. Just for example, you can take the example of rectangular plate with circular hole. So this geometry is symmetrical. So instead of going for the analysis of the entire plate with circular hole, you can go for the analysis of the quarter plate, and you can apply the results over the entire plate. You can draw the suitable sketch for this rectangular plate, and you can explain the relevant points related to this question. Next is with formula explain Jacobian quality criteria. So this you can explain with the help of Jacobian formula. Next is explain the concept of mesh density with suitable sketch. So here you can explain the mesh density, the same P and H refinement concepts you can add into the answer part. Apart from that, say for example curve boundaries are there in one particular geometry. So for those curve boundaries you can go for the large number of elements or higher number of elements, so that the accuracy of the result will be good. So next is what is the criteria for element selection. So basically there are three criteria are there for the element selection. First is the geometry, second is type of analysis, and third is the time required for the analysis. you can elaborate these 3 points, okay, with your suitable content. Then 2 of the properties you can explain: define aspect ratio and skewness. So apart from that, few questions are there that can also be asked, which are: why quality of meshing important in the FEA? Okay, this question can also be a part of your end semester examination. The quality of the meshing is important in order to get the accurate results. So with this first point, you can go for the proper content in your answer. Then next is explain the effect of mesh density in critical regions. Okay, critical regions, especially curve boundaries, or if special feature of the geometry is there, in that case you can go for the mesh density, and it is definitely going to affect the result of your analysis. Next question is: why quality of meshing is ensured and the convergence of element in FEA formulation is achieved? So basically, what is convergence? Convergence is, say for example, one particular geometry is there. If you divide that geometry into 100 number of elements, okay, and you run the result. Okay, after that, after running the result, you get the result of the analysis. So after, in the second stage, you go for the 200 element and you get the results. You compare the result of the first with the second. After that, you go for the 500 elements, then you compare the results. But after 500 elements, you find out that there is no considerable change in the output results. So that is called as convergence. So I hope that this video will be useful for you at the time of revision for this unit number 2 during the examinations. Thank you very much.